Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series in applied electronics. We start with the new section interference in the syllabus for basic physics. We are going through that the section on optics. We saw them in the earlier lectures. We had a series of lectures on aberrations, and we now pass through the section on interference. This is a very important section because of the fact that this phenomenon of interference, which we will be discussing from lecture 11 onwards, could be explained only on the basis of wave theory of light. Before going further, let me go through the contents of the lecture. Namely, we will discuss the basic concepts of interference, constructive and destructive interference, coherent sources, conditions for constructive and destructive interferences, and then lastly the phase change that the light wave will undergo when it goes from a rarer medium to a denser medium. As I told you just now, the fight between Newton and Huygens, which theory will be the proper theory to explain the phenomenon of interference. By now, you will be knowing that it was Newton who proposed that light will be traveling in the form of rays. You got a source of light here, it reaches my eyes, and according to Newton, light travels in the form of a straight line, and he proposed what is called the corpuscular theory of light. Now, what are corpuscles? The corpuscular theory says that light consists of packets of energy called corpuscles, and light rays are made up of these corpuscles, and the light rays travel in the form of a straight line. Now, this phenomenon of interference, about which we will be discussing in detail, this could be explained only on the basis of what is called the wave theory of light, which was proposed by Huygens, and not the corpuscular theory. You should remember, the Newton's theory of light will not be useful or is not valid. It cannot be used to explain this phenomenon of interference. Not only this phenomenon of interference, in the lectures to come, we will be discussing about diffraction of light, polarization of light, and so on. These phenomena of interference, diffraction, and polarization could be explained only by assuming light to be made up of waves and not rays of light, as was proposed by Newton. So, Newton's theory is inapplicable. It cannot be used to explain the phenomenon of interference. We should treat the light coming from the source, this source or any other light source, light coming from the sun or the moon or any lamp, the light is made up of waves, and we will be discussing this phenomenon of interference on the basis of what is called wave theory of light. As I told you, it was proposed by Huygens, and so we will be concentrating on waves. So, let us start from the fact that you drop a stone in a pool of water. You drop a stone in a pool of water, and what happens? The water medium is disturbed and you get waves, right. Light, the water particles start vibrating. As I told you in the last lecture, I told you about transverse waves and longitudinal waves, and in the case of water medium, when a stone is dropped, the surface, it gets disturbed, water is disturbed, and water particles will be vibrating up and down, and the wave will be propagated in this direction, a direction perpendicular to the vibrations of the water molecules or water particles. The wave will be traveling in this direction. The vibrations of the water medium will be will be subjected to vibration. The particles will be going up and down. The wave will be traveling in a direction perpendicular to the direction in which the particles will be vibrating. And anyway, you can see a beautiful wave when you have a pool of water and drop a stone, and you see nice water wave. You see the wave, you see the ups and downs, right. The water wave is propagating, and this disturbance and the wave that is traveling on the surface of water, or the light wave, is a transverse wave, right. This is a transverse wave we are talking about. Light wave is an example of a transverse wave, that is what I told you in the last lecture. Wave properties, and you should know this is called the amplitude, that is the maximum displacement. This is some displacement from the equilibrium position. When you drop a stone in a pool of water, this is the equilibrium position, and the water particle can undergo a displacement. At this point, it will undergo a displacement of this magnitude, or at this point it will undergo a displacement of this magnitude, but the maximum displacement that will be experienced by a water particle or a water molecule, the so called amplitude, right. This is the amplitude, and this distance that separates the two ups or the two crusts, you got the maximum vibration here, and similarly maximum vibration in the negative direction. This is called a crust, and this will be called a trough, as I will be showing in the pictures to come, and the distance that is separating the two humps is called a wavelength of the wave. The light is propagated in this direction with the velocity v, and this is a transverse wave, and this picture clearly shows when the wave is getting propagated in this direction, and you have what is called the amplitude here, the maximum displacement is called the amplitude, and this is called the wavelength, as I told you just now. This is a crust, right. This is another crust, and these are the troughs, right. From this is the equilibrium position in which the water molecule will be present when the stone is not dropped. When a stone is dropped, then the water particles move up and down, giving rise to the propagation wave, that is the wave that you see here, and this is called the wavelength, as you know, and these are the crust. The maximum displacement is called a crust, and the displacement in the negative direction, that is from the equilibrium position, the water particle will go up, right. Then the water particles in some places will come down, right. So, this is, you can have plus A and this is minus A, and both of them will be getting cancelled here at some point. Okay. This is one complete cycle, right. This is one complete cycle in any, for any wave. This is again equal to lambda. Now, let us go to the case of two stones being dropped. Now, on the left hand side, I show the wave being developed on the surface of water when a single stone is dropped. Now, I will do other thing, namely I drop two stones simultaneously, two small stones simultaneously on the surface of water. What happens is there will be disturbance again. You got from the point the wave is getting developed, and from here also the wave is getting developed. Now, what happens here? You see the two waves, a wave is getting propagated from here, the another wave will be getting propagated from here, and so you have a wave going like this, right. You have got another wave coming like this, right. You see them, the ups and downs on for the stone, that is wave being developed from the falling of the stone at this point. Similarly, when the stone is dropped at this point, another wave is getting developed, and these two they interfere, they come, they overlap with each other, right. Now, what happens to the overlap? What happens when the two waves they start overlapping? So, you talk of interference, it is superposition or combination of two waves, combining waves together in such a manner, so as to cause either what is called constructive interference or a destructive interference. You can see now you have two waves, you have got a wave here, okay. Another wave is coming here. Now, when the two waves meet each other in such a manner that the crust meets the crust, right. You see here crust meeting a crust, and so wave 1 plus wave 2, the two crusts are meeting each other, that is you have got a crust here and the two crusts are meeting each other, then the displacement will be a plus a 2 a. If a is the amplitude, two identical waves, a is again the amplitude here, a plus a will be 2 a, the amplitude it gets summed up. So, wave 1 plus wave 2, this gives rise to what is called the reinforcement or constructive interference. Similarly, a trough meets a trough, you see a trough here and a trough here, and you have got minus a and minus a, and there will be minus 2 a. Here it will be plus 2 a, right. In any case, the crust meets a crust leading to a bigger crust of a greater amplitude, a trough meets a trough, then another a bigger trough with a or a trough with a greater amplitude. Similarly, a trough meeting and a crust is meeting a crust, and so on. And so, this wave that you get here by combining the two waves, wave 1 and wave 2, the combination takes place in such a manner that the amplitudes are getting added. If the amplitudes are getting added, as I show here in a figure on the left side, that is the example of a constructive interference, right. Then you go to the other case, what is called the cancellation of the two waves or destruction of the two waves. It is called a destructive interference. So, you have a wave here, the crust is here, they have got a wave here. What do you observe now? The crust is here, at the same point from the wave 2, instead of getting a crust as you had here, you are getting a trough, right. You are getting a trough, and so the wave 1 and wave 2, as I told you, this is plus a, and what about this? This is minus a. So, a plus minus a, what will happen? It will become 0. Okay. So, this is a positive displacement, maximum displacement, amplitude plus a. At the same point, you have got from the second wave minus a. So, when a crust meets a trough, the amplitude of crust is a, the amplitude of trough is minus a. When a crust meets a trough, then a and minus a will be getting cancelled. So, the resultant will be 0. Okay. So, the resultant is 0 here. Okay. This is what you observe when two waves meet each other, and this again I show the interference that will be caused on the surface of water when two stones are dropped simultaneously. So, as I show here once again, you have got a wave here, when you have got another wave, these two waves are being added, or the two waves meet, or the two waves interfere. Now, the nature of the two waves is such that the displacement here is a, the displacement here from the first wave is again a. When the two a's can be added, right, 2 a, when the two a's can be added, resulting in a displacement 2 a plus a 2 a, and similarly you will be having 2a here in the negative axis. So, this is an example of constructive interference, a crust meeting a crust, and similarly a trough meeting a trough. Okay. On the other hand, you look at this wave, there is a phase difference or a path difference. I will come to these terms and explain these terms in a better way in the time to come. And what you observe here at this point, there is a crust and there is a trough here, right. So, a crust is meeting a trough. So, what happens? The displacement will be 0 and the resultant will be 0, and you have got a trough meeting a crust. There is a crust here, trough here. So, whenever a crust is meeting a trough, the displacement will be 0. When a crust is meeting a crust or a trough is meeting a trough, the displacement will be maximum, giving rise to what is called a constructive interference. Now, what do you understand by constructive interference? I told you about phase difference or a path difference. What is phase difference? Now, let us all sing a song. You sing Jana Gana Mana, right. I sing the national anthem Jana Gana Mana. You also sing, but when I say Jana, if you say Jana, then there will be constructive interference. If I say Jana, you say Gana, and some other person say Mana, Jana Gana Mana, there is a phase difference, right. There is a time gap is there. When I utter a word Jana, you should also, all of you should repeat the same word Jana without any phase lag. At the same time, when I say Jana, all of you should say Jana, then there will be the resultant loudness or intensity displacement will be maximum. If 30 people say Jana and all of them tell the same word Jana, then there will be loud voice Jana, Gana, Mana. Okay. Then on the other hand, if I say Jana, somebody will say Gana, then someone says Mana, then what will you hear? There will be noise, there will be chaos, there will be, it is a destructive interference. When I say Jana, all of you should utter the same word, then that is an example of a constructive interference. There is no phase lag. When I utter a word, you should also utter the same word at the same time. And on the other hand, if there is a time delay or there will be a phase difference or there will be a path difference, that will lead to what you call confusion, or there will be no proper signal, right. In the next diagram, when you have a displacement like this, when you have another wave having a slighter displacement like this, when these two are added, the resultant is not 0, but you have a crust here and trough is not having the same amplitude. If it is plus A, if it is minus A, what will happen? The resultant will be 0. Hope you understand. If you have got plus A and you have got a wave here, okay, if it has got the displacement exactly minus A of the same height in the negative direction, then the resultant would have become 0. But now, in this case, the resultant is not 0, it has got, this has got the 100, this is minus 70. So, there will be 30, right, plus 30, something in some unit. Okay. So, this is plus A and this is C, the wave C, we have got a displacement which is not as high, great or as equivalent as this height. This is in the negative direction, but a smaller, lesser height. So, there will be a resultant wave will be there with a smaller amplitude again in the negative direction, the positive direction, negative direction. This is a destructive interference, right. It is not perfect destructive interference. A perfect destructive interference is the one for plus A, you will be getting minus A, right, at the same point. Now, this is an example of a constructive interference. Okay. Irrespective of amplitudes, you have got plus A, I mean A 1 here, A 2 here, A 1, A 2 are to be summed up. Why are they to be summed up? Because at the same point you have got A 1 here, A 2 here. When you sum up A plus B, you can sum up. Similarly, you can sum up at the same point, the trough is here, trough is here, the two troughs can be added. And similarly, the crust here, you have a crust here at the same point. So, the two crusts can be added, leading to increased amplitude. Here you get a wave with a decreased amplitude. You see a wave here, because the amplitudes of the wave A and that of C are of having different values or of different values, right. You got A having a greater height, for C it is a smaller height. So, A plus C will be an example of a destructive interference. Here the amplitude, resultant amplitude will be larger, here there is a decreased amplitude. Ultimately it will become 0 if you have got exactly the same amplitude here. Okay. So, these pictures would have made you to understand what I would like to convey to you, the so called the concept of constructive interference and destructive interference. Then again I should make you to remember when the two waves should be occurring at the same point, right. At the same point when the two waves are meeting with the same amplitude plus A, then the resultant will be 2 A, or minus A minus 2 A. There should be no phase difference, and I will should make you to understand there will be the constructive interference only if the two sources which are emitting light should be coherent sources. What do we understand by coherent sources? Again you go to what you call a constructive interference. You have a crust here, you see at the same point the crust of one wave meets the crust of the second wave, the first wave, second wave, the two crusts meet. So, the resultant that you are getting will be of a greater amplitude, right. It is a summation, right. It is a constructive interference. Trough is meeting a trough. Okay. The two troughs are meeting. So, this is a resultant trough. Again the two crusts are meeting, the resultant crust and the trough, and I would like you to go to the beach and experience for yourself the crusts and troughs, the beautiful waves that you see in the sea. When you go to the sea and sit near the sea shore, you feel that a wave with a greater amplitude is coming, and you will feel that it will come and touch your feet, because the amplitude is very large. A wave will be coming with a large amplitude, and you will feel that the wave will come and touch your feet. On the contrary, what happens is the wave does not come so much as you expected. It is because the wave that which came earlier, it will go back and interfere with the incoming wave in a destructive way. You go to the beach and feel the constructive interference and destructive interference. What I would like to tell you is, you see a wave coming with a large amplitude, and you will feel that as if the wave will come and touch your feet, but on the contrary the wave does not come as much as you expected. It goes back because of the fact that the earlier wave which came, it will go back and cause a destructive interference. The amplitude of the incoming wave will be killed by the wave that is returning back. So, that you can experience, you can see for yourself how the waves are meeting each other, leading to what is called a destructive interference, that you can see when you go to the beach. And so, the interference pattern that is involved in the water waves is shown here by two vibrating sources. You can have two sources which are made to vibrate and produce the constantly the waves on the surface of water, and the waves will be going with crusts and troughs alternately. You got a crust, trough and so on. So, either leading to A is what? Note the regions of constructive interference, that is A is the crusts of the two waves are interfering, leading to constructive interference. On the other hand, B is the point where the darkness, right. B is a point where a crust is meeting a trough, leading to what is called destructive interference. Okay. A crust, when two waves are meeting, if the crust meets a crust, there will be a constructive interference. If a crust meets a trough, there will be plus A and minus A will kill each other. Now, we will pass on to the summary of today's lecture. The summary will go as follows. When two waves interfere with each other, either there will be constructive or destructive interference. For interference to occur, the two light sources should be coherent, Now, the details of coherence we will see in the next lecture. We will have the following questions now. What is meant by interference? Explain destructive and constructive interferences. With this, we come to the end of the lecture number 11, or the first lecture in the series of the section on interference, which is a very interesting section, because it makes you to understand whether Newton is right or Huygens is right. Obviously, Newton is wrong. Okay. That is the corpuscular theory will not be able to explain the phenomenon of interference. With this, we come to the end of this lecture. Thank you.